All right, let's start 1.5. Now 1.5 has to deal with all the properties we know about pre-algebra and how we apply it into algebra. So this would be sort of maybe you've seen things in pre-algebra, and we're going to try to see how we can formulate general expressions to put into algebra. Like for instance this right here. We understand that 3 plus 5 is 8. And we also understand from pre-algebra that 5 plus 3 is 8. So it doesn't really matter the order in which you add numbers, or add positive numbers here. So this is called the commutative property of addition. So in this case, that is a property that we're going to carry into algebra. And the way we carry it, we're going to put variables on this. So let's start. So there it is, the commutative property of addition. So it says a plus b is really the same thing as b plus a. So it doesn't matter how you add, you will get the same exact number either or. Same thing has to do with multiplication. It really doesn't matter which way you multiply. You can do a times b or b times a. It doesn't matter which order. So 3 times 4, 4 times 3, they both turn out to be 12. All right, how is this useful? Because many times in mathematics you'll have something like this. You'll have y times 2. And what we can do is we can really change it into 2 times y, or just write it as 2y. And so there's a little example how we're going to use that in algebra. All right, that's two properties. Let's keep on going. Then there's something called the associative property. And this one really talks about grouping. How do you group things together? If you're adding three numbers, you can add the last two numbers together, then the first one. Or you can add the first two together, then the last one. And in this thing, in terms of associative property, you want to think about basically the parentheses are moving. That's what you want to sort of notice. The parentheses around the B and the C, now the parentheses around the A and the B. So the change here is the parentheses, almost like a change in focus. All right, again, multiplication does the same thing. You should notice right away to say, you know what, that's kind of weird. Subtraction does not work here. There's no subtraction, there's no division. Subtraction and division don't have these properties. All right, so let's jump to a few example problems to start with. All right, number one, before you start writing anything down, what I want to do is, I want to do it, let's say the very, very slow way to do this. And the very slow way to do this is actually observe the commutative and associative property. And then what we're going to do is we're going to say, you know what, let's get a faster way to do this. And that's going to be by sort of thinking about those properties, but doing them a much faster way. So let's do this. Don't copy me on this one. Just kind of think with me here. If I were to use these properties, then what would happen? Let's just say my focus would be around the x and the 5. And what I'm trying to do is I'm trying to simplify this. Okay. What would tend to happen, well, what would happen next is I'm going to shift my focus from the x and the 5 and the 7 and the x. And so what do you think property? I guess let's do this here. I'm going to do the next portion and you tell me what property we're using. So going from here to here, notice the only change has been is the parentheses. So we're technically using the addition, the associative property of addition right here. All right, next what I'm going to switch the 7 and the x. So the x is going to go first, then the 7. So notice the parentheses did not change. What has happened is I switched the numbers around. 7 plus x is the same thing as x plus 7, and that is the commutative property of addition. Okay, then what I'm going to do next one is to change my focus to the 7 and the 5. And right here, from this step, notice my switching of parentheses. And so this would be the associative property of addition. And finally, we simplify 7 plus 5 is just a 12. Now, I used to torture my high school students, and what I used to do is I used to make them write down each property as they do it. And this one took, let's see, 1, 2, 3, 4, 5 steps to do this. In algebra, what we do is instead of using these 4 properties and thinking through each of the properties, we just collect like terms. And that's sort of like the fast way to do these 4 properties. So collecting like terms, if you go back to 7 plus x plus 5, collecting like terms is the fast way to do all these properties here. So now I want you to copy me. Now I want you to look at this problem and say, okay, are there any like terms? Well, the 7 and the 5 are like terms. So the x does not have a like term. So the x is going to go down as the x here. Plus 7 plus 5 is 12. So notice in one single step, I've simplified the problem completely. But you realize whenever you're adding like terms together, what you really are doing is you're doing the commutative and the associative properties. That's kind of what I want you to understand. Like terms are built upon, collecting like terms are built upon these four properties we just discussed. Anyways, let's go for it. So the easy way here. The only thing is whenever you see parentheses, you want to get rid of them. Sometimes it's a distributive property. Other times, if you just see a plus sign or a minus sign right in front of the parenthesis, there's really nothing to distribute. With a minus sign there is, we'll get to that. But a plus sign, what we're going to do here, if you see a 3 plus and in parentheses 7 plus x, we just drop the parentheses. Okay, again, we could do 5 steps here, or the quick way is to collect like terms. X is going to go first for us. 3 plus 7 is 10. Done. There's 2 steps and we're completely done. Some of you guys could have went actually directly from the problem to answer. That would have been cool too. Okay, same thing here. Forget about really the properties that we covered. But it's going to be 3 times 4. You're going to distribute this, or take this 3 times the 4x, and we'll make it 12x, and you're done. All right, again, just kind of reminding ourselves about the 4 properties. Probably the reason why you have not memorized those 4 properties is because they're not that important, and because like terms really takes care of all those 4 properties. All right, let's go on to some other ones here. So how do we simplify this? So now we're looking at fractions and whole numbers. And so what we do here, whenever you see a fraction multiplying a whole number, we like just to make everything into fractions. So now 7x really becomes 7x over 1. Then I get to reduce stuff or multiply them across. In this case, since I have a 7 on top and a 7 on the bottom, I can just reduce those 7s. So technically I'm dividing by 7 on top and dividing by 7 on the bottom, which leaves us 1 on top and a 1 on the bottom. Whenever you're left with just 1s on the bottom, you don't really need to put a 1 there anymore. That means you just have one whole piece. But on top you have a 1 times x. In this case, how about you just have x? Let's go to the next one here. 6 on the outside now. The fraction is inside the parentheses, so let's make that 6 on the outside a 6 over 1. Again, the 6's should cancel each other because 1's on top, 1's on the bottom. So we're left with just 1's for that. And notice what I have. I have 1 times x, which is going to be x. And then 1 and 1 on the bottom. There's nothing else here. There's no multiplier, so we just forget about it. We don't write the 1 on the bottom. Okay, see? You can try it yourself if you need to here. But that 15 has to change into a 15 over 1. And I'm going to try to reduce this. Can't cancel it because I'm at the same number, but 15 and 5 would reduce down to a 3 on top and a 1 on the bottom. So again, notice just 1's on the bottom here. So for the final answer, how about 3 times 2 is 6 times x is just 6x. Okay, the property that I think you are familiar with from pre-algebra is the distributive property. And there's 2 illustrations in your textbook, how we think about distributive property as maybe like a geometric representation. There, we'll talk about it just a second here, but the property, if you have a number on the outside, multiplying, and I know by multiplication because of that little parenthesis or the start of the parenthesis here, and it's a b plus c. So what we can do is we can multiply the a times the b, and then the a also has to multiply the c, so then it becomes a times c. And if you do that, this answer on the left should equal the same thing as this answer on the right. Just a quick illustration geometrically, how does this work? Say you have a square, say you have a rectangle here. And you know that one rectangle is 3 inches across, 5 feet high. 3 inches across, 5 inches high, the second rectangle is 4 inches across and 5 inches high. What we could do is we could just add up this whole entire side together. We would say this whole entire side is really 7 inches, and 7 times 5 gives me 35 square inches, so the area of this whole entire big rectangle is 35 square inches. Alright, let's try again just an illustration about the distributive property. So the second one, we do this here. How about we take individual rectangles here? So really this is 3 inches, this is 5 inches. And so if we get the area of just this particular rectangle 1, we're going to get 3 times 5 or 15. And then we're going to take the area of rectangle number 2 here. So again, the length of this here is 4 inches. The height is 5, so 4 times 5 is 20. And 15 plus 20 is 35, which is the same exact answer we got for the previous problem. Again, just illustration that it doesn't matter which way. If you can add it, then multiply, or multiply, then add it. Using the distributive property, you're going to get the same answer. Alright, so let's go for it. Some problems for us to try. Hopefully you already tried it, but really what's happening here, you have to distribute this 3 over to the x and then over to the 5. So 3 times x is 3x. 3 times 5 is 15. Alright, and don't hesitate to pause this if I'm going too fast. Alright, with B, again, we're going to distribute the 8 to the 2x as well as the 7. So 8 times 2x is 16x. 8 times 7 is 56. And again, just practicing the distributive property. Alright, again, try it yourself first if you would like. I'm going to set up the answer as well here. Alright, 3 distributing the 3 to the 5x as well as the 2y. So 3 times 5x is 15x, and 3 times 2y is 6y. And getting a little bit more lengthy here. The 6 has to multiply the 4a and the 5. So 6 times 4a is 24a. 6 times 5 is 30, but you have this little 9 at the end. So again, this whole concept of collecting like terms. We look at this and say, you know what, 30 and 9 are still like terms. So 24a plus 39 should be the final answer. Alright, let's work with fractions now. So applying the distributive property, we're going to have to multiply or distribute 3/5 to the 5x as well as the 10. Alright, again, if you can do this in your mind, perfect. And if you can't, I'm going to do it the slow way. So here's what my slow way. It's going to be 3/5 times the 5x. So I'm going to write it as 5x over 1. Plus 3/5 times the 10, but I'm going to make it as a 10 over 1. Then I'm going to reduce each of these here before I multiply across. So going back to the first multiplication here, I see a 5 here, I see a 5 here. I can cancel off the 5s, so now it becomes a 1 here, a 1 there. So notice I just have 1s left on the bottom. Again, no need to do anything there. It's just going to be a whole number, but 3 times 1 times x is 3x. Over here, cancel off the 5 or reduce the 5 and the 10 down to a 1 and a 2. And again, just 1's left on the bottom. And final answer at 3x comes from the first multiplication. 3 times 2 is 6. And that comes from your second multiplication. Alright, so you should grasp the idea here. So especially on the last few problems that we're doing, on number 3, when we did that, notice whenever you multiply the number and that number is actually the same thing as the denominator, these two really will cancel each other. So whenever you see this here, 7 times a 1/7, you know the 7s are going to cancel each other. So here you're just left with an x. So then the 7 has to multiply by 3, so then you get your 21. So again, if you're multiplying by a number which is the exact same as the denominator, just cancel it off completely. Okay, C has this same concept here as well. And again, just try it yourself, see if you come up with the same answer here. So looking at this one here, I'm going to distribute the a to the 2, a also to the 1 over a. So let's see, a times 2, this would give you a 2a. That's easy, that's going to be 2a. But again, you're multiplying this a to a 1 over a. You know the a's are going to cancel each other out. So as the a's cancel, you're just left with this little 1 on top. So final answer a times 2 is 2a. A times 1 over a, the a's cancel because one's a numerator, one's denominator, and so that 1 is the only thing that stays. Okay, but sometimes it's not the same number. Sometimes it's a multiplier of the number. So again, the easy way, if you can do it, I'm going to do it step by step here as the book does it. So 15 becomes a 15 over 1. So 15 over 1 is multiplying 4/5 x, plus 15 over 1 is multiplying the 1/3 y over here. So then again, start simplifying as far as we can. So 5 and 15 becomes a 1 and a 3. 3 and 15 become a 5 and a 1. And then again, putting it all together here, this would become a 3 times 4 times x, or 12x. This is 5 times 1 times y, or 5y. All right, let's go on to some more properties, and then we'll work a little bit with that. Some more basic properties here. First of all, something we've seen before, something called the additive identity property. Just means this: if you're adding a number with 0, you just get that same number back. Or if you have a 0 and you're adding that number to 0, you still get that same number back. So additive identity property. Basically addition by 0. And addition by 0 does not change the number. How about the multiplicative identity? What do you multiply by so you get the same thing back again? And obviously it's 1, because a times 1 still gives you the a, or 1 times a still gives you a. A multiplying by 1 does not change the number at all. And something we've seen in, I think, section 1.3 is the whole concept of adding opposites. If you were to add opposites, a plus negative a, those will cancel each other out and just leave you as a 0. Okay, and one more property to go. So the multiplicative inverse property. So now the question is what multiplies a number to get you to 1? And we've seen those in practice already here. If you have the number a, what you multiply is 1 over a, and those two a's will cancel, leaving you just with 1's. That's actually the definition of what it means to be a reciprocal as well. A reciprocal is multiplied to 1. So a and 1 over a are reciprocals of each other. Alright, so just a quick little 8 problems to do here, just to see if you can name the property that you're using in order to simplify the illustration here. So let's go for it. So I see x plus 5 plus 3. I see x plus 5 plus 3. So there's been no number changes. But I noticed the parenthesis has changed its focus. So it was over the x plus 5. Now it's over the x plus 3. So if you guys agree here, this is the associative property of addition. Alright, with B, let's see what's happening here. And again, it's just you recognizing the properties, just to make sure we know. Looks like the 8 has distributed to the x as well as to the 5. So this would be a distributive property. Okay, going over here. Now let's see, 4x plus 9 and 9 plus 4x. Hey, the numbers got switched. But again, I'm talking about addition here. That means I can add no matter which order I go in. That's something called the commutative property of addition. And D. Let's see what's happening here. This one's a little tricky one here. Let's see, notice you got the 4 plus a plus b. Over here you got 4 plus b plus a. So it's the parentheses did not go to a over a and b over here. If they did those, if it went from here to the a and the b, we would call those associative. But here, the only change to this problem is the b and the a got switched. So a was a plus b before, now it's b plus a. So really it was commutative property of addition. Okay, 4 more just to try. Again, just to make sure we are familiar with these properties and can name them when we see them. So 5 plus a negative 5 equals 0. So when adding its inverse, or I'm sorry, adding its opposites, you get 0. What property is that? That is called the additive inverse property. Adding its inverse or adding its opposite. Okay. F, let's see, so 6 plus 0 plus 5, now it's just 6 plus 5. So it looks like if you add with 0, you just get the number itself. What property was that? Again, that's the additive identity property. All right, and G, let's see, 1/8 times 8 gives you 1. This whole concept of multiplying by its reciprocal, but the algebra property is the multiplicative identity property. Okay, and H, this one's a little bit toughy here. So let's look at the numbers themselves first. 5 plus 7 plus 6. This is 7 plus 5 plus 6. Huh, that's weird. Okay, so let's see. It looks like the 6 is in the same position, but it looks like the 5 and the 7, they switched. That'd be commutative. But then also the parentheses also switched. Look at this. It was around the first 2 numbers. Now the parentheses are on the last 2 numbers here. So this one is 2 properties put together as one. This is the commutative as well as the associative property of addition. Okay, and that was 1.5. 1.5 is really having to do with all the different properties that come over to us from pre-algebra. So the next 2 sections we're going to be dealing with here is just multiplication and division. So we're going to multiply and divide. How does that work? Again, we're going to throw in some negative numbers into here as well. So let's go for it here. Just a quick illustration here. Suppose you owe 5 shares of stock and the price share drops by $3. So whenever you share stock, it's always per share. So technically you've lost $15, but how does that work out mathematically? So again, since you owed 5 shares of stock, that's the number of stocks you share. This is your loss of $3, so 5 times negative 3 should give you a negative 15, total of $15, but it's for a loss. So we want to make some rules for this. All right, and probably the easiest rule here is this right here. It's if you have the same sign, whether it's be positive, 2 positive numbers or 2 negative numbers, if you multiply them together, you're going to get a positive answer. So a positive times a positive is a positive. Also a negative times a negative is a positive. So those both give you positives. If they have different signs, then they'll give you negatives. So 3 and a negative 5 gives you negative 15. Negative 3 and 5 gives you a negative 15. So here's a rule. Positive if both numbers have the same sign. Negative if the numbers have opposite signs. That's probably the easiest rule I found. All right, these problems are going to be pretty easy. Try them yourself first, and then we'll check our answers together. All right, let's go for it here. So positive 4 and a positive 6 obviously makes 24. 4 times a negative 6, since they're different signs, it's going to give you a negative number, and then we just multiply the numbers themselves. So negative 24. Negative 4 and 6 makes a negative 24. Again, different signs, therefore negative. On D, both of them are negative, therefore it will give you a positive. So how about a positive 24 for that? And again, because they were both negative, they both have the same sign, therefore it turned out to be a positive answer. Okay, jumping to some more problems here. Again, try it yourself if you can go ahead of me. All right, let me try this as well here. So for A, I'm going to just list you the answers here. Should be a negative 35. For B, they're both negative, so therefore the answer should be a positive 24. C, different signs, so therefore a negative, and 9 times 2 is 18. And for D, both of them are negative, it's a positive at the end, so 4 times 5 is 20. E, a negative and a positive make a negative, and 2 times 6 is 12. For F, a negative and a negative make a positive, so 7 times 4 is 28. Okay, let's get just a little bit more complicated here. What happens if we're multiplying 3 or 4 or 5 or 6 or 7 numbers together at once? Well, there's a little bit of a trick here. And the trick here for multiple numbers, or numbers, more than 3 numbers multiplying each other, 3 or more numbers multiplying each other, is you just look at whether they're even or odd number of negatives. So the first one, there's 3 negatives here, so you know it's just going to be a negative. Alright, and then you go for the numbers themselves. So 4 and 6 make 24, and 24 times 3, whatever that's going to be. You have to multiply it out here. But I got a 72 as I multiply it out, so therefore the final answer should be a negative 72. Okay, for B, let's go for it here. There's some multiplication and addition and subtraction here. So this one's going to go a little slower. First of all, for multiplication, 4 times negative 5 is negative 20. 7 times a negative 2 is a negative 14. And what I like to do, I like to keep the positive here anyways. And that's going to be a negative 14. Let's put in parentheses here. And this one is going to be a subtraction. We're going to change that to addition. We're going to take the opposite of 8 or a negative 8 and put it right at the end here. So now I got everything in terms of addition. So negative 20 plus a negative 14 would make negative 34. And negative 34 plus a negative 8, again both signs, add them up. 34 plus 8 is 42. So final answer, how about a negative 42 is our final answer. Okay, and if you got this, you're doing good. So this one means negative 3 taken to the third power. So there's 3 negative 3's multiplying each other. And again, even or odd. Odd number of negatives, right? Because it can be a negative times a negative times a negative. So therefore the final answer will be a negative. Then I just have to deal with the numbers. What is 3 times 3 times 3? Well, 3 times 3 is 9. 9 times 3 is 27. So final answer here is a negative 27. All right, now let's put exponents here. All right, nothing to do inside the parenthesis. Here, there's nothing to simplify here, nothing to simplify here, but we have these exponents to simplify. So let's go for it here. So negative 2. Negative 2 here. This is going to be negative 3 times negative 3. So negative times a negative is a positive. 3 times 3 is 9. All right, bring down the minus 4 over here. This is going to be negative 2 times negative 2 times negative 2. So negative 2 multiply itself 3 times. But, so we got a negative times a negative times a negative. That will surely be a negative answer because there's 3 negatives that are multiplying together. And then 2 times 2 times 2, which should be an 8. Still not done. Negative 2 times 18 is negative 2 times 9 is negative 18. And this one, what we think about here is we have this concept of this is technically a sort of like a negative because I can make this 4 into a negative. And so we think of this as almost like a negative 4 times a negative 8. And a negative 4 times a negative 8 gives you a positive 32. Alright, different signs over here. So we've got to do a little bit of work here. Since they're different signs, I know I have to figure out the difference, right, between 32 and 18. So I got to set it up. What's the difference here? I got to borrow. So 12 minus 8 is a 4, and 2 minus 1 is a 1. And so positive or negative? It's going to be positive because the 32 is the bigger number and it's positive. So final answer should be just 14. Alright, this one. Let's look at this here. I got myself, looks like maybe even distributive property here, or we could just simplify this. Let's simplify it. 8 minus 3 is a 5, so everything else remains the same except for 8 minus 3 becomes a 5. Alright, I can't put the 10 and the 2 together because I have multiplication here. And this is subtraction, this is multiplication, so this has to come first. So 2 times 5 is 10, and 10 minus 10, it gives me a 0. Alright, let me do E. Let me do this again, just real quick, just to illustrate the little point of that distributive property here. So remember, distributive property works, and it works all the time. So if you think about this right here, I can distribute this little -2. I call it a -2 because of the little minus sign in front. So again, subtract 2 or -2, those sort of are interchangeable terms in mathematics. So instead of simplifying what we did over here, 8 minus 3, let's actually distribute this -2 into here as well as into here, see what happens here. So 10, now this is going to be a -2 times 8 or -16. Then it'll be a -2 times a -3 makes a +6. And the only thing I got to do here, I'm going to change this subtraction to addition by placing a little positive or plus sign, but then I got to take the opposite of 16 or a -16. Cool, let's go for it here. So 10, what's 10 and a -16 going to make? 10 and -16 is going to make a -6. And then what is -6 added with a +6? And again, this whole concept, remember, if you're adding its inverse, they're going to cancel each other out. Gives you just, just gives you just a 0. Okay, moving on. Multiplication between fractions. How do we do that? Well, we multiply numerators, we multiply denominators, but before we do that, a little faster way is to figure out if and maybe I can reduce the numbers first. And we've already seen that already. So 3 and 4 won't reduce, 6 and 7 won't reduce, 3 and 7 won't reduce, but 6 and 4 will. By 2, 2 can go to those. So let's take half of 4 is 2, half of 6 is 3. At that point, now let's multiply. The only thing is, don't forget this little negative right here. So it's on top, it's a -3 times 3, which is -9. On the bottom is 2 times 7 for 14. Alright, this one, a whole number times a fraction. Again, just make that in both into fractions. And let's reduce the 4 and the 8. So that becomes a 2, that becomes a 1. Don't forget this little negative right here, but 1 times -1 is a -1. 1 times 2 is a 2. So -1/2 is our final answer. All right, and this one, notice that both of them are negative. So this is a negative, that's a negative. So negative times a negative, I'm just going to put a little plus plus. So therefore I know my answer is going to be positive at the end here. And notice the 9s are going to cancel because you got 1 9 on top, 1 9 on the bottom, and the 4s are going to cancel. So really got, hey, everything canceled. The negatives canceled, the 1s canceled on top, the 1s on the bottom canceled. So again, at this point, then the answer is still just 1. So basically you divided a number or multiplied a number with its reciprocal, gives you a 1. Alright, let's take just a little bit of time here looking at, again, those graphs and charts, being able to read them and recognize what they're trying to say. So if this looks like, first figure is activity and how many calories are burned, I guess, yep, in 1 hour by 150 pound person. The other graph is whole concept of fast foods, various types of fast food, and the calories that go with it. So let's see, if a 150 pound person burns 265 calories per hour bowling and then eats a 510 calories of a McDonald's Big Mac, find the net change in calories for the person if he's going to bowl for 3 hours straight and then eat the Big Mac. So let's go for it here. So I'm going to start it off like this here. So he's going to eat 1, and it doesn't matter which way we're going to add this up here, or subtract it here. So I'm going to add the positive side first here. So if he eats 1 Big Mac at 510 calories, then he's going to start burning it off at 265 calories per hour. He's going to do that for 3 hours. So let's see what happens here. Multiplying the 3 and the 265. If we do that, that's going to be 15. That's going to be 18, 19. Still carry the 1. That's going to be 6 and 7. So now we got 510 subtract 795. Again, switching it to an addition of a negative number. And doing a little bit of work here should wind up with a negative 285. So what is his net change after doing that? He has burned off Even with the meal, he's burned off 285 calories. So an English sentence that would make sense, he would say he lost 285 calories. And again, just getting us comfortable with reading charts and graphs and seeing how they would apply to the numbers that we're dealing with. All right. And again, it says apply the associative property, but what you really want to do is you just want to simplify it and be done. Because if you do that, again, it's going to be like 5 or 6 steps, and we don't want to do that. We want to be able to quickly finish off the problem and keep on going. So in this case, a negative times a positive, I got myself a negative. 4 times 5 is 20, and then the x comes with it here. In this case, positive times a negative is a negative. 4 times 6 is 48, and the variable is a y. In this case, I'm going to put a little 1 underneath the negative 3, and I'm going to make that into a positive because 2 negatives make a positive, and then I'm going to get rid of those 3 because I have a 3 on the bottom, 3 on top. So notice I just have 1's on the bottom. So my final answer is just going to be 1 times 2 times x, or just 2x. Alright, distributive property. Let's see how this works. And again, just practicing here. I've got to multiply the negative 5 into the 2x as well as the 3. So negative 5 times 2x gives you negative 10x. And negative 5 times 3, and again, because you're going to get a negative, we put it out here, and then negative technically just changes into a subtraction operation. And you get your 15 there. Okay, this one. So notice I have a numerator of 1, or technically a negative 1, and then I have a denominator of 4. I want to multiply this into the 3x and the 6. At that point, I'm going to make everything into fractions. So I can really deal with each of these pieces here. So negative 1 times 3x is negative 3x. 4 times 1 on the bottom gives you just a 4. Here you got a negative times a subtraction symbol, or technically we think of this as still a negative. So negative times a negative is a positive. And 1 times 6 is 6, 4 times 1 is 4, and then this is good, but this one actually still gets to be reduced. And if you leave it in this form, it technically will be wrong. Because again, with any fractions, you have to reduce it to its simplest form. So 6 and 4 can be reduced down to a 3 over 2. So there's your final answer. All right, and the question is, Mr. H, can I make this into a 1 and 1/2? Absolutely. That'd be fine. That'd be the same exact answer. Okay, going on to C. Got to distribute that negative 4 to the 2x as well as the negative 7. And again, negative 4 times 2x is negative 8x. Negative 4 times negative 7 makes positive 28 minus 3. Collecting like terms, 28 minus 3 makes a 25. So final answer would be negative 8x plus 25. Alright, and we have talked about the arithmetic sequence before. Now what we're going to do is we're going to go to a geometric sequence. And if you remember from the previous class, an arithmetic sequence means you're adding a number. You're doing some kind of arithmetic to it, and then you're going to be adding or technically subtracting a number to get the next number. A geometric sequence now is talking about multiplication. If you want to write down multiplication next to this, that's fine too. So whenever you say geometric sequence, you're just trying to say multiplication. And again, it could be that you actually are saying division, or maybe multiplying by a fraction. So let's go for it here. So find the next number in the sequence. That's what we want to do. So 2 becomes a 6, and then 6 becomes a 18. What are we doing here? It looks like we're multiplying by 3 each time. The pattern holds, so 18 times 3 gives you 54 as your final answer. Alright, this one, a little bit more tricky. It goes from a 1 into a negative 2, then from a negative 2 goes to a 4. Notice you got a little negative symbol here. So it comes from a positive, becomes a negative, then becomes a positive again. So at this point you should think about, I'm multiplying through with some kind of negative because I'm changing the signs, and then again This is an easy one because 1 times whatever it's going to be, it's going to give you this one, so it has to be a negative 2. The negative 2 times negative 2 is a positive 4, and then positive 4 times negative 2 gets you that negative 8. Okay, and of course a more difficult, challenging one. Got fractions on our hands here. What do you multiply 2/3 to give you 2/9? And what do you multiply 2/9 to give you 2/27? And the thing that we should see is the 2 on top stays. So technically multiplying by 1 on top. But what do you multiply on the bottom from a 3 to get you a 9? 3, obviously. And what do you multiply a 9 to give you 27? Is a 3. So really, it's a multiplier of 3 of 1/3 each time. The 3 multiplies the 3 to give you the 9. And then again, multiplying by 1 to keep everything the same. Okay, so if that's the pattern, let's see if that holds up for the next one here. So 2/9 times 1/3 to give you 2/27. Yep, that works out. Therefore, to get the next term, we just have to multiply 2/27 times 1/3. And multiplying that out, you get an 81 here. So therefore, the final answer is 2/81. All right, 2/81. All right, moving on to 1.7. Now we have our division in our hands. The previous section was multiplication. So now let's look at it. As we talked about it before, there's numerous notations for division. You can put the division symbol here. You can write it as a quotient. You can write it as a multiplication of a number and a fraction. That technically also is division. All right, so let's take a look at a few things here. So try it yourself first. I'll fill it in. What we should understand here, just same thing as multiplication here. So positive divided by a positive will stay a positive, and 8 divided by 4 is a 2. 8 divided by negative 4, positive divided by negative is going to give you a negative, and 8 divided by 4 is a 2. This little box, I put a little box around it because on the answers to this particular section for the matched problems, it actually gives you an incorrect answer. This would be the correct answer. Answer should be a negative 2. All right, positive divided by negative divided by a positive is going to be a negative, and 8 divided by 4 is a 2. And negative divided by negative is a positive because the negatives cancel, and 8 divided by 4 is a positive 2. So there's your various answers here. So just like multiplication, if you have the same signs, whether positive or negative, you're going to get yourself positive answers. If you have different signs as you divide, you're going to get yourself negative answers. All right, so let's go on a little further. Again, try these yourself first. Give you a few seconds to go ahead. And let me write down each of those answers here. So 12 divided by 4 is a 3. 15 divided by negative 5 is a negative 3. Negative 12 divided by 3 is a negative 4. For D, both of them are negative. You know you're going to have a positive answer, and 24 divided by 8 is a 3. E, answer is a negative 6. F, the answer should be just a 5. And G, the answer should be a negative 13. All right, let's move on to dividing fractions. And this I think you learned a long time ago here. We technically don't divide fractions. What we do is we figure out a way to make it into a multiplication problem as opposed to a division problem. And the way we do it is we change the second number, or the number following your operation of division. We change that number into its multiplicative identity, or you could say reciprocal. Sometimes it's given as keep, change, flip. But you keep the first fraction exactly the same, you change the operation to multiplication, and you flip or take the reciprocal of the second number or the number following your division symbol. All right, at this point, you can finish off the problem here. So 3 times 3 is 9 on top, 4 times 1 is 4. And again, as I mentioned, you probably want to keep it as improper fractions. The answer in the back of the book will pretty much almost always be improper fractions. All right, for B, negative 1/4 stay the same. Change it to multiplication, put an 8 on top, 3 on the bottom this time, and this time we can reduce. How about 4 and 8 goes into a 1 and a 2? Final answer, a negative 2/3. All right, whole number here, so 9. 9, I'm going to change it to 9 over 1, just so we have both of them as fractions here. Change it to multiplication. And again, we talked about the negative sign. When we do reciprocals, we still want to keep the negative sign on top. We don't like negative signs on the bottom of fractions. At this point, nothing to cancel, so let's multiply across to a negative 27 over 2 is our final answer. Okay, so now let's do a little bit of simplifying here for a little while. Let's go for it here. So with quotient bars, that's the new thing here that we've not seen before. With quotient bars, you have to simplify whatever is on top of the quotient bar first, simplify whatever is on the bottom of the quotient bar next, and then finally you get to divide. So in this case, 5 times negative 3 is a negative 15. Simplify that on top. 6 stays as 6, and now we can see if we can reduce this. So yeah, that's right. 6 goes in this. 3 goes into 6. 3 goes into 15. So how about a 2 and a 5? And final answer, negative 5/2. For B, let me rewrite this problem as 27 on top and a negative 3 plus a negative 6 on the bottom. So just change the subtraction to addition. Took the 6, changed it into its opposite, which is a negative 6. Now let's see this here. So 27 on top. This is a negative and a negative. We're adding them up, so therefore this would be a negative 9. And how about a final answer of negative 3? Alright, some more complicated problems here. Let's try it here. Can you simplify this? And again, the whole concept is you're simplifying the numerator as much as you can, simplifying the denominator as much as you can, and then you can see if you can reduce it some more. So for A on top, 4 times negative 3 is negative 12, plus 7 over 10. Still simplifying the top until we can't do it anymore, so negative 12 plus 7 is a negative 5 over 10. Now we can start dealing with it as a fraction. So I can reduce that both top and bottom by 5. So how about 5 here, 5 there, and I get myself a negative 1 over 2 is my final answer. B, lots of work here. So on top, keep on doing until you're done. On the bottom, keep on simplifying that until you're done, then see if we can reduce anything here. So let's try it. So 3 and negative 8 makes negative 24. So on top here, I got a negative 24. Let's see, 5 times negative 4 is a minus 20, or adding a negative 20. I like to just keep everything addition if I can, because then I don't have to change it to change subtraction back to addition. Okay, negative 1 times 3 is a negative 3. And technically negative 4 times 2, or minus 4 times 2 is a minus 8. So notice I haven't simplified yet completely, either the top or the bottom. So I go back to the top, I'm going to simplify this here. Negative 24 and negative 20. They're same signs, so therefore they have to be a negative 44. This one, I'm going to change this to addition, so how about a plus here? How about opposite of 8, which is a negative 8? Hey, same signs, so therefore let's add up the 3 and the 8, which makes 11, and we put a common sign of negative. Okay, and then with division, remember this negative on top was going to cancel with this negative on the bottom. So really it's 11. How many times is 11 going to 44, which is just 4. Okay, Getting a little bit more complicated, now putting exponents into the situation. So looking at this here, let's see, simplify this. This is 2 times 2, which would make a 4. This is going to be negative 3 times negative 3, or a positive 9. On the bottom, this is just subtraction here. And again, if you need to change this to addition of a negative 7, that's fine. Or if you could think about it as 6 minus 7, that'll just be a negative 1 if you can. But 4 plus 9 is 13. And 6 plus a negative 7 is negative 1. So therefore, final answer is negative 13. Okay, B, again, order of operations. Let's see how this works here. 2 plus 4 is 6, and we're still going to take it to the second power. On the bottom, though, we got individually here. So this is 4 times 4, 16, minus 2 times 2 is 4. So on top, it's still 6 to the second, or 36. 16 minus 4 is 12, and 12 does divide into 36 exactly 3 times. So there's 3. Okay, getting a little more complicated here. Now we're going to introduce fractions into the, variables into the situation. Let's put x's in there and a's in there. Let's see what happens here. So, seen this before, or something similar. Let's make that 12 into a 12 over 1. Can I reduce anything? Absolutely. 12 and 6. So 6 becomes a 1, 12 becomes a 2. Notice again, you got just 1's on the bottom. That means everything canceled. You have whole pieces now. So 2 times x is 2x. Going over here, distributing the a. So it's going to be a over 1 times 4 over a, minus sign, again, distributing the a to the 3, a over 1 times 3 over 1. If you want to do it that way, again, I'm totally breaking it down, but if you can skip a few steps here, that's fine too. So the a's cancel completely. That's cool. Final answer here is 4 on this side. On this side I already have 1's. Nothing's going to cancel, so how about a minus 3a? We normally like to write the number first and then the variable afterwards. Okay, this you'll see sometimes in the textbook. Sometimes we usually don't like the number by itself in front. We actually like the variable first and then any other number. So we can switch this around. We're going to take this little negative 3a, put it in front. Take this 4, put it in the back, and again 4 is positive, so we're going to put a plus 4. So that's the way we'll normally see these. Alright, and the last concept here for 1.7 is this whole division by 0. Why you cannot divide by 0. And so in pure mathematics, what we have to understand is there's really no such thing as division. There's always multiplication. So let's talk about this here. If you say 6 divided by 3 is 2, what you technically are saying is there is a number called 3 that I multiply 2 to get a 6. So there has to exist this, this number 2. So there is a number called 3 that if I multiply by 2, it gives me 6. So I see the 2 here and the 2 there. Alright, let's take a look at the whole concept of 0 then. 0 divided by 5 is equal to 0. Is that true? Yes, because if I take this 5, I say what number times 5 can give me 0? So 5 times a 0 gives me 0. That's why. So I have this little number called 0 that I can work with. Alright, so let's go back over here then. 5 divided by 0 is n, and we're going to use n as just to represent some kind of number. Is this true? Is this possible to do? So 5 divided by 0 is n. So if you go over here, what number times 0 would give you a 5? That's my question. What number times 0 can give you a 5? And the answer is it is not possible. So because it's not possible to multiply a number times 0 to give you 5, therefore it's impossible to divide 5 by 0. So again, just one of those questions like, how come you can't divide by 0? Well, there's the answer. Alright, so this is the end of section 1.7.